Um, Hi, I have another example for you from section 3.9, this time number 16. I think it's a reasonable question. The question is reading that at noon, like 12 o'clock noon, ship A is 150 kilometers west of ship B. What does that mean? That means that so let's say we have ship A in here, west of, so ship B is somewhere on the right hand side. Okay, ship A is sailing east at 35 kilometers per hour. So east going to the right, going this way, and at 150, so let's say this is my horizontal, let's call that x, and so dx dt equals to 35 kilometer per hour. What else do we know? Ship B is sailing north, and ship B is sailing north at the 25 kilometer per hour. So if ship B is west and going north, so ship B is going this direction, okay? And so at sometimes, as time goes by, this hypotenuse is going to get bigger and bigger and bigger. Well, let's see. In the beginning, the problem is saying that ship A is 150 kilometer west of ship B. Ship A is sailing east at 35 kilometers per hour. Ship B is sailing north at 25 kilometer per hour. So that means that if this is my x, this is my y, I can say dy dt equals, okay, dy dt equals to 25 kilometer per hour. Now here I have to be careful though, because ship A is moving eastward, and so the distance that the distance of initial distance that was 150, x equals to 150, okay, kilometer in the beginning. So what does that do to our problem? That means that this the horizontal side is going to be 150 minus x. So in the beginning, they're 150 miles apart, but ship A is moving to the right, it's moving east. And ship B is moving north, going up. So far, so good. Well, if I count the horizontal is 150 minus x, and we call the vertical y, let's call the hypotenuse, say z. Okay, that's good enough. Now, what else do we know? Well, the question is asking how fast is the distance between the ships changing at 4 p.m. So we are going to have to find dz dt, okay? So need to find dz dt. So let me say find dz dt in 4 hours. Remember the problem said that at noon, so it's 12 o'clock. So now if you're talking about 4 p.m., it's 4 hours after that. Okay, as it is many times the case, I have to work with a right triangle. Okay, so I'm going to go to the next page. I'm going to claim that z to the second, which is my hypotenuse, equals to 150 minus x to the second plus y to the second, just using Pythagoras. And if I take the derivative using in relation with time, I'm going to have 2z dz dt equals to 2 times 150 minus x to the power of 1 times the derivative inside, which is going to be negative 1 times dx dt plus 2y dy dt. So the value of z, we're going to have to calculate in 4 hours. Dz dt, we need to find out, but both dy dt and dx dt are given to us. No. So we know that at 4 p.m., that is in 4 hours, okay, my x equals to 140 and my y equals to 100. Remember that 4 times 25 kilometers per hour is 100, and 4 times 35 is 140. Okay. And to find z, I'm going to go ahead and say that z equals to square root of, okay, the adjacent side, which is 150 minus 140 to the second power plus 100 to the second power. And so z equals to square root of 10100, and that roughly equals to 100.5, and that's going to be kilometer. So now I have the value of z, I know dy dt, I know dx dt, I know x, I know y. So now it's time to plug in the numbers. So I have 2 times square root of, my z was 10100, dz dt equals to 2 times x, which is my whole, or my adjacent, which is 150 minus 140 times negative 35 plus 2 times 100 times 25. Okay. And now I can divide both sides of this equation by 2. So if I do that, I'm going to have square root, let me change color, square root of 10100 dz dt equals to 100 times 50 times minus 35, and that gives me 2 times 100 plus 25. So I'm going to have, the first part is going to give me minus 350. The second part is going to be giving me 2500. So dz dt equals, now I'm going to divide both sides by square root of 10100. So this gives me 2150 divided by square root of 10100, and that roughly gives 21.4 kilometer per hour. So as you can see, the hard time, I should say the hard part of related rates is to have some sort of geometrical shape, something that we can have, we can take the derivative in relation with time. I hope you like this example.